Okay, so these are referred to as the special kinematics equations. It's the ones you're allowed to use in grade 12, because I wouldn't even consider going through this with a classic grade 11. And let's start with equation number 1, EQ1. All right. Remember this old classic, A equals delta V over delta T? Many of you probably have already sort of started to use this already. You just haven't realized it. I remember I've had more than one kid say to me, couldn't I just do it like this? And I'm like, yeah, that's really good, actually. Remember also that delta V is VF minus VI, right? So what I'm going to do is I'm going to take this version of delta V and I'm going to put it in there. Okay, because this delta V and that delta V are the same delta V. And so now I get A equals, instead of delta V, now I'm going to get, I'll put it in red so you can see it. I'm going to have VF minus VI, and that's all going to be over. And I'm going to let the delta T just sort of, become just T. Because generally, like delta T means the change time, but 99.9% of the time, what's the initial time reading? 0. Right? The initial time reading tends to be 0. So it's just the amount of time that's elapsed, but most of the time that time is the reading of the clock because the initial is 0. Okay? And now I'm going to do a little bit of formula manipulation. How do I get the T to the other side there? It's attached by a divide by T, so how do you get it to the other side? Multiply both sides by T. Well done, Josh. And so I get AT equals VF minus VI. And for some reason, people like to have the VF by itself. So I'm going to write that as VF on the right. And then minus VI, when it goes to the other side, it becomes, or when I get rid of it on the right-hand side, I add VI to both sides, right? Give and take. So I add VI to both sides, and I get VI plus AT. And most people write it this way, sort of the opposite way. And you could probably go from that step to that step on your own. And that, my friends, is special kinematics equation number 1. VF equals VI plus AT. And it sort of eliminates, you know that whole bit there where VI is 0, you got to show that delta V, and it's all the same thing, it's a big waste of time, right? That sort of eliminates that. And if you stop and you think about it, it makes sense. The final velocity is whatever the initial velocity is, plus whatever the acceleration multiplied by the time is. This is the change in the velocity, right? That's what that part is. So that's known as special equation number 1. And I'm going to leave that on one page and then go to the next one. Okay, here's where the degree of difficulty ramps up. That's pretty easy so far, eh, Austin? Just a warm-up activity. Are you getting worried? Equation number 2. Now I have to pause here and make sure I get this right. I'm just gathering my thoughts for a second. Okay, since displacement is the area under a VT graph, almost. Okay, so if I have a graph like this, okay, let's say that I am interested in the displacement between the 2 points Ti and Tf. Remember, what we're doing here is we're trying to come up with a formula. Okay, so the area that I'm talking about is that shape there, right? That area right there. What shape is this? Let me see if I can draw it. Okay, imagine that's a good drawing. What shape is that yellow shape that I just drew? Does it help if I do this? Martin? You don't know? Does it help if I draw it like this? Oh, I heard someone say it. Trapezoid. Think of the thing that the elephants stand on in the circus, right? It's kind of that trapezoid shape. I always think of that for some reason. Okay? It is indeed a trapezoid. Sean, do you know the formula for the area of a trapezoid? Yes. You may not want to admit it. I can understand that. Anyone? No idea? It's actually relatively simple when you see it, right? So it's, if I call that one side 1 and call that one side 2 and I call this the height, does that help? I know you've probably seen it at some point. If you sort of like squeeze it in at the bottom and stretch it out at the top, you're kind of finding the average of the two sides, right? Kind of making a rectangle. So it's in fact side 1 plus side 2 divided by 2. It's the average side multiplied by the height. Okay? But how does that relate to this shape right here? Okay? Now, in a trapezoid, the traditional trapezoid has like the two sides that are kind of meeting towards each other, right? Coming towards each other. It could also be this way, by the way, too, right? But it doesn't have to be. One of those sides could be, if you want to call it that, like straight down. The definition of a trapezoid is a four-sided figure that has only one pair of sides that are parallel. So all it means is these sides can't be parallel. So it doesn't have to be sort of like that diagonal shape. Okay, so if I look at this one here, this is side 1. Let's go back to yellow if I can. Can I do that? This would be, oh no, it's not going to let me. Side 1 and side 2, and this is going to be the height, right? But remember, what did I do with that? I rotated it, didn't I, right? Right? So where's my side 1? There. My side 2 is there, and my height is actually that one right there. Now, how does that relate to the original labels of TI, TF, VI, and VF? Okay, that's sort of the key idea here. Once I get this, you guys, then the algebra makes sense. Okay, so if H is actually TI, it's the difference between those two, right? What do I call the difference between TI and TF? Delta T. Right? And side 1 and side 2, well, side 1 is simply equal to, there, that's simply VI. And this one here is going to be V2 or VF, right? Everybody with me so far? And again, I'm not expecting you to walk this path on your own, just you're on a guided tour. When you get to the end, you get a check mark. Okay, so now I take my area of a trapezoid and I write this, but instead of S1 and S2 and H, I'm going to write it with my VI and my VFs and my Ts, right? So side 1 we agreed was VI, and side 2 we agreed was VF divided by 2 times the height, which is, in this case, the height is delta T. Hey, Mervyn. Yeah, I think Mr. Bernat has them. And what are we trying to find here? What is this here? Well, this is the area, which is the displacement. Okay, so I'm writing another formula with d and vi. I'm doing all that, right? And it's gonna make a lot of sense when you get to the end. Okay, getting close. Let's go back to this new friend of ours here, equation number 1. Vf equals vi plus at. And I'm going to replace this Vf with Vi plus At. I'm going to take this, and I'm going to plug it into right there. And I'm going to put it in red so you can see it. So you got D equals Vi plus, and now the Vf becomes Vi plus At, that's right, all over 2 times, and again, I'm going to let delta t just kind of disappear and become just plain old t. You can leave it as delta t if you want. It's a little cleaner. The books always like to leave it in there, and it just makes it more complicated than it needs to be. Okay, now it's just a matter of cleaning up some like terms and stuff. So I got d equals, I got Vi plus Vi, which is x plus x is 2x, so Vi plus Vi is going to be 2Vi plus At all over 2, but the whole thing is multiplied by t. I told you he was going to stretch your algebra skills. Okay, last step. Combine. These 2's will cancel, right? When I cancel those 2's there, can't do that? I can cancel those, but I have to leave that divide by 2 with this guy here, right? Okay, so can I write that as, are you okay with me writing it as, those 2's will cancel, can I write it as Vi plus 1/2 At? Can I write it like that? Okay, but that whole thing is multiplied by t, so in other words, it's going to be Vit plus 1/2 At squared. And that, my friends, is special kinematics equation number 2. And do you see why I keep it from the grade 11s? Right? There's a reason for it existing. It doesn't just appear. It's not dogma. There's a reason for it. There's a clear, logical explanation for it. You can use it now. You've been down the path. D equals Vit plus 1/2 At squared. What does it get rid of? Remember having to all those questions before where you had to, anytime you had to find the displacement, you had to find the average velocity? Remember having to do that all the time? I always had to convert to average velocity. Gets rid of all that. Okay, it's very handy. Warning, equation number 3, crazy algebraic fractions. Don't worry, I'll walk with you. You should start a fresh sheet of paper. You should start a fresh sheet of paper. At least a fresh side. Special equation number 3. Okay. So I'm going to say, take equation 1 and isolate t. What we're going to do here is we're going to create a formula that eliminates t. That's the goal. Take equation 1 and isolate t. So equation 1 was Vf equals Vi plus At. So isolating t means get t all by itself. So the first step is to get rid of the Vi or the A? Vi. The Vi. Vi goes to the other side and becomes minus Vi, right? Or we subtract, sorry, I actually got to rephrase this. We subtract Vi from both sides, right? And we're going to get VF minus VI. When I subtract VI from that side, I'm left with just AT. And now to isolate the T, A is attached to it by a multiply, so to get rid of it, I'm going to divide both sides by A, and I get VF minus VI all over A is equal to AT divided by A, or just T. I have isolated T. And now replace T in equation number 2. Here's where the different colors comes into play for me. So D equals, let me write it out like this. D equals VIT plus, let's do it this way. That's already in black. D equals VIT plus 1/2 VT squared. And I'm going to replace that with, that's going in there and in there. And Martin is already worried. I can see. Don't worry, Martin. I've been down this path before. I know my way back. I'm going to expand. See how much space I've left myself down here? Because it's going to get big, isn't it? D equals. So that's going to be VI, and I'm going to go to black here, times VF minus VI all over A, plus 1/2 A, and then T squared is VF minus VI all over A, and that is squared. What should we do next? And I always ask that question, and I always get the same kind of answers. Just stop and don't do it, Mr. Bennett. We're going to multiply this VI into there, and we're going to have to square this out, right? Okay. So I'm going to do sort of two things at once here. So D equals, and can I write all in blue now? D equals, so VI times this is going to be VI VF minus VI squared all over A. And I try to go slow. And can I write 1/2 A? Are you okay with me just writing that as A divided by 2? That's okay? All right, now this squaring nonsense here. How do you square a binomial? If I give you, just on the side here, if I give you x plus y squared, how do you do that? Grade 10, I think, maybe? Anybody remember? In the good old days, we taught FOIL, but I don't think they teach that anymore. They still teach it? Excellent. Nothing wrong with a little bit of FOIL. What does FOIL stand for? First, outside, inside, last, right? So the first are x times x, which is going to be x squared. The outside is going to be x times y, and then the inside is another x times y, so you get 2xy, and y squared is going to give you y squared. You guys remember seeing that kind of stuff? Yeah, I'm looking for sort of reading facial cues here. Okay, so now apply that to VF minus VI squared. So it's going to be first, oh, I didn't. VF squared, right? Outside, inside. The outside is going to be VF times VI, and the inside is going to be VI times VF. So there's two of them, and it's negative. And we usually put the VI first, right? We usually put the X first, but in this case we put the VI. I don't know why we do that. We just do. So that's going to be minus 2 VI VF. And I'm going to end off with VI minus VI times minus VI, which is plus VI squared. So I just FOILed that. And what happens with the a on the bottom? Does it have to be squared too? Yes, it does. Yes, it does. A squared. Okay. Do you sense some cancellation happening in the future? Hopefully, right? At this point, most math students, most physics students, they sense it. They're just not quite sure where it's going to happen. Okay. What I do now is, why is that? Oh yeah, no, I know what I do here. No, that's crazy talk, Josh. Will this a and this a squared, will they cancel out? Is there any cancellation that'll happen there? Here and here? Yeah, this one can go away, and then this one just becomes an a all by itself, right? Right? So now, and I hate this step because really this step is just rewriting a bunch of things, but it's kind of necessary. So I do apologize. So really you get VI VF minus VI squared all over A plus VF squared minus 2VI VF plus VI squared all over. I got a 2 on the bottom and I got an A all over 2A. Okay, so all I did there was cancel that A and the A squared, left an A on the bottom and multiplied the 2 in there. And it is a pain in the butt to have to write that whole thing out again. And I have to remember to go slow and make sure everyone gets this step here. And now I always ask the question. Where? VF squared? VF, it's the same thing on top of that. VF squared minus 2VI VF plus VI squared. Okay. If you've got fractions like 1/3 plus 2/6, how do you add them? Common denominator. What does that mean? It means put the bottom, change the bottom to the same number, right? Change them both to, in this case, change them both to 6. So how do I need a common denominator here. So A and 2A, so I need to make a common denominator of 2A. Right? So all of this one's going to be exactly the same. And to make 2A on the bottom, if I multiply the bottom by 2A, I have to multiply the top by 2A. So I get 2 VI VF minus 2 VI squared. Right? You're just multiplying the top by 2. And then this one's all the same. And it starts to condense now here, you guys. VF squared minus 2VI VF plus VI squared all over 2A. You glad I saved this for a Friday?
Yeah.
Okay, now when you add fractions, what do? You add the tops and put them all over that common denominator, right? Which is 2A. So we're going to add. Two VIVFs minus 2 VIVFs. Right? Add them together. Minus 2 VI squared plus a VI squared minus VI squared. Should I put it out front? No one likes that, right? I'll put it over here. Minus 2 VI squared plus a VI squared is a minus 1 VI squared. And what's left? This guy right here. Look at that great big long line that I drew. And it all canceled down. In fact.
Yeah.
Now, we do sort of get a little bit of cleanup. They like it expressed in the terms of VF squared. So I'm going to multiply both sides by 2A. And that means over here I'm going to have I multiply the left side by 2a, I'm going to have 2AD. And if I multiply the right side by 2a, the 2a's cancel. I'm left with VF squared minus VI squared. And then they like to have the VF all by itself, and I don't know why. So the final formula, what's it going to be? Can you do this part in your head? Can you write VF squared equals? VI squared comes first. The minus VI squared, I add VI minus VI squared to both, sorry, I add VI squared to both sides, and I end up with VI squared plus 2AD. And that, my friends, we are at the end of our journey. Special equation number 3. We have eliminated time. It's a lot of work just to save a little time. You never have to go through that again.
Thank you.
You just have to be here and write it down, go through it with me. Okay? So that solves problems where there is no time. Now, I hate to tell you this, but there's a fourth equation.
Oh.
But this one I am not going to derive. There, and you can put this on the bottom of that sheet if you want. If you've got space, you don't need to start a new one. I'm just going to give it to you. Do you remember equation number 4? It starts with x equals minus b plus or minus the square root of b squared minus 4ac all over 2a.
Yeah.
You remember that one? Is that grade 11?
Pre-cal too.
Yeah, but it's grade 11, right? Like if you just started grade 12, then yeah. Okay. Did you ever see the formula derivation for that? Or did they just say, here's the quadratic formula and it works? I think they just say, here it is, and it works, right?
Yeah.
You don't want to see it.
I want to see it.
You go Google it up, Tanner. There'll be some nerd that's got it up on YouTube. Guaranteed. And it's not me in this case. Okay? Now, I've had a few people in the past that have never seen that before, so I just want to clarify what this is. That's when you have an expression like ax squared plus bx plus c equals 0, and you're solving for x, right? In the physics world, it tends to be something like this. 2.3 t squared time plus 4.6 t minus 17 is equal to 0. And you have to solve for time. We're going to use it in those situations. Not for a few days, but I figured I'll throw it in here. Okay? You need to be familiar with that and be able to use it. Okay? If you have a graphing calculator, or if you have Desmos or something like that on your phone, I will allow you to use something like that. But you do need to be able to solve a quadratic. Okay? That's all I have to say today, more or less.